All right, I'm here to waste your time for a few minutes before I introduce you to the real star. My name's Sarah. I work at a company called Stack Overflow, if you've ever heard of it. My favorite band is Hanson, and my favorite color is royal blue. I knew that was really important to all of you here. So I'm going to be talking today a little bit about my story, some information about why it's important for kids to code, an introduction to what we do at Jewelbots, and then I'm handing off this talk to the real star of the show. Okay, so I am part of the generation of folks that became coders because we didn't have friends when we were little. So I was 11 when I started coding in the early 90s. I started doing it. I was a homeschool kid, and I found out that you could make friends through your computer, and I thought that would be really fun. I went to high school, and I took a C++ class, and I was like, this is really neat. I think like this. I want to do this always. And I ended up studying computer science at Penn State, and then it's been almost 20 years since then as an individual contributor and a manager after I sold out. So I started talking to, when I started in this field, I started looking around, and I was like, wow, there's not a lot of people that look like me. And this seems to be a fairly homogeneous group, and so I started talking to folks that I coded with, my male peers, about why they started coding. And I heard from them that usually around the middle school age, they discovered something like a game or an open or a community that got them really excited, and they were like, awesome, when I grow up, I'm going to be a game developer. And then they found out that game developers don't make any money, so they decided to write JavaScript, and here they are now. So we started thinking about ways that we could reach girls and female identifying folks with products that are a little more feminine and exciting for that group. And everyone here knows how important it is to get kids coding for lots of different reasons. I really love this stat of thinking of the jobs that don't exist yet, that kids need to learn about what they're going to be doing. I think the cool thing about it is it's really up to their imagination, right? So preparing them to invent these amazing jobs is super important. And it leads to a lifetime of creativity and curiosity. So in 2015, we did a Kickstarter for Jewelbots. Jewelbots are smart friendship bracelets that light up when your friends are nearby, and you can code, and they're open source. We shipped over 10,000 Jewelbots to over 30 countries around the world. We started getting feedback about our products, and one thing we heard from parents it turns out I don't have kids, but I know lots about kids, ask me anytime. I heard about the plastic box that they keep in their rooms, where the toys go that kids play with, then kind of get over it, and it goes in their box of plastic. I heard from parents that kids enjoy Jewelbots, but with short attention spans and the desire for new things all the time, was there something that we could do that would be new and interesting often? So we started working on science kits. So one thing that you might notice is that when boys create, we call it building, and when girls create, we call it crafting. But really, it's just the same thing. It's making stuff. And in the world of crafting, there are a ton of concepts that are science-focused and amazing. And so we started building science kits that have a lower price point and allow kids to build using their imagination and learn about interesting concepts like geology and chemistry. So we've been shipping those for a little while. We've been getting great feedback so far, and people have been making awesome stuff. Today, you're going to see Ellie demo a kit that isn't even on sale yet. If you go to jewelbots.com/node interactive, all lowercase, all one word, you can see the Hello World LEDs, which is a kit that incorporates Arduino and light-up LEDs. Kids can make awesome badges for their backpacks or their t-shirts, but I'm going to stop going on because I'm an adult and adults are boring. I'm going to introduce you to someone who I look up to a lot. Ellie started a YouTube channel about Jewelbots, and now she does awesome things where she codes things like Jewelbots and lots of other neat stuff. She releases a video every week. One neat part of this, I think, is that her dad, who's here today, was the person who coached me through my first open source pull request. So it was really neat for it to come full circle, and now I get to work with his daughter. So I'm super pleased to introduce you to Ellie Galloway, who's going to talk to you about, and do some, the first person here with guts to do some live coding on stage. Super happy to introduce Ellie Galloway, who's going to talk more about building with Jewelbots.
Hello, my name is Ellie Galloway. I'm a Jewelbots ambassador and have been for a couple years now. I'm going to be covering a few things today, and that will be my story, which is not very long, but it's very special to me. I'm going to show you how I make my badge, which I will explain soon what that is. I'm going to show you how I code my badge, which is the live coding, which is my favorite part. And then women in coding, history and importance. So there's a big history behind that. I'm going to show you that. So in the presentation, when I start live coding, I'll need your help. So if you could raise your hand or something, that'd be greatly appreciated. Okay, so here's my story so far. So I grew up in California, which made it really difficult to pack for this trip. But it was really easy for my dad because he is a programmer for Microsoft, and he travels around the world teaching different people about code. So I started to get pretty curious on what all those numbers and stuff meant, and so I asked him about it, and he started to teach me through games like Unity, coding for Minecraft, and different stuff like that. He showed me Jewelbots, and I begged him for one, and eventually he gave in. Okay, so in 2018, I spoke at my very first conference at Red Hat, which was the best time of my life, and it was just really fun to do. And so now, I'm going to show you how I make my badge. So if you don't know what a badge is, it's a little felt thing. So it has an Arduino, which is I'll explain what all these things mean in a bit, and LEDs, so you can code it and it lights up and makes cool things, so people can play around with it and do different codes. Okay, so here's what you'll need, an Arduino Gemma, so I just mentioned that. Think of this as a computer. So this is what you code. This is basically like a laptop or something. And then you'll need conductive thread and needles, and what these do is it's like a power cord. So it plugs from your computer, and then the LED sequence is your final destination. It's the outlet, just to make sure the code is running smoothly. And you'll also need felt for your workspace. So anything optional is decorative, different things like that. So here's your plan. You don't need to make it as detailed or anything. I just did it because, well, I'm speaking. But you will need to map out a few things, and that's your Gemma. You need to map out the ground, or GND, which is a metal plate, also the D1. And then you want to map out your stitching from that, and then from that, the LEDs. So you might want to make note that you need to have the negative and positive in a certain order. You can't just switch it around. That has a huge thing to do with the code. So you'll need to make sure that the negative is on the ground side. And also make a note that if you cross the threads, it will lead to a short circuit. Both of those things will. So you just want to be careful because it might start smoking. Ask me how I know. So step 2 is sew loops around the ground. So the GND, basically this just makes it so it's secure, because this can go in your clothing and stuff like that. It's going on fabric, so you're going to use it a bit. So you do want it to be secure and securely on the thing that you want it to be on. And also, it's kind of hard to actually have the code running if it's barely on there. For instance, if we go back to the other example of the power cord and everything, you want to plug it in right, or it won't work and charge. So that's very important. Okay, so now you're going to sew the sequence on. And so again, you want to make sure the negative and positive sides. I'm just reminding you again because I forgot, and yeah, it started smoking. So Now, you're going to repeat on the other side. So what I mean by this is you're just going to finish that line, tie a knot, and then you're going to start a whole new stitch and go from the D1 to down and sew across all the LEDs. And I forgot to mention, you do want to sew loops around the LEDs too. But after that, just tie a knot, don't cross or anything, because, well, I know a short circuit. Lots of ways you can mess up in this. So then you're done. You can decorate if you want. Again, you can add embroidery floss. You can take inspiration from me. I embroidered on one, and then I made it look like a Polaroid camera on the other, just to have some fun with it. Okay, so now you're done, and I'm going to show you how I code my badge. But before we do that, we are learning a whole new language, and I don't just want to copy things down because you want to actually learn something from it, or there's no point in doing it. So I'm going to translate all of these things and make it easy to remember. So turning on and off is high and low. Basically, the LED voltage would be higher, so that's how you know high because it's brighter. And then lower voltage would be dimmer or completely off. Then starting off the code, this is a fun one. I did digital write because you're digitally writing. I thought that was funny. So now we're stating the LED as pin mode. I think of it as the LED sequence as a pin and what mode you're putting it on. So now we can get to the live demo. Okay, so now we're going to start at the beginning and void setup. So I'm going to do pin mode to start off the LED, and I'm going to do LED underscore built in. And now I'm going to do a comma. And so what we need here is to give the LED output. So I'm just going to write output right here, and it's as simple as that. Okay, so now we're going to go down here, and I'm going to basically make a blinking on the gemma. So I'm going to do digital write. Now I'm going to do the same thing, LED built in, comma. Okay, so if we want to start it off, I'm going to turn it on, so high. Okay, and now I'm going to delay. And I'm going to delay this for 500 milliseconds, which is equivalent to a half second. Then I'm going to do digital write. Again, I'm going to do LED built in. Okay, so I'm just making sure you're paying attention. If we wanted to make it blink, which would we put next? Would we put high? Raise your hand for high. Okay, low? Okay, yeah. Good, you're paying attention. Okay, so I'm going to do low. Okay, so now I'm just going to delay it for the same amount of time to make it even. Okay, so now let's see how it works. Let me find my plug. Okay. So here is the gemma. Yay, okay, it worked. So let's get back to the presentation. Okay, and now let's go to women in code. So this is history and importance. Okay, so as you can see from these numbers, they're pretty sad, like it's pretty uneven, right? I want to change that. So here's the weird part. You might be like, well, maybe women just aren't interested in code, but that's very far from the truth. So when I was researching this topic, I saw that Ada Lovelace and Charles Babbage worked together to create the very first computer. And Ada was the first one to program it. So as you can see from the picture, it's a pretty old model. Like, this isn't one you just see lying around. But she still worked with what she had, and she programmed it. And she was the very first, too. So who invented computer software? So Grace Hopper invented the very first system. And this was back in the 1950s. She also worked in the Navy, and that's really impressive because not a lot of women worked in the Navy back then, and so she's a really great role model. So who invented the computerized telephone? So Ernest Schneider Hoover created the first computerized telephone, and this revolutionized modern technology. And this was even back in the 1960s to 70s. So why aren't more women in code? So here's what I found. So they didn't really have robot toys in the 1950s, but this is kind of a more recent thing, and that's when we see the decline. So I'm not saying that these toys aren't good, because nowadays we see a lot of male programmers, and that's because those kind of electronic toys go more to the boys' aisle. So girls don't really get inspired that way, and it makes it hard. For instance, people wouldn't be interested in the topic if they're not seeing how it works and how it's fun. So either girls had to deal with it, or if they were like me and snuck into the boys' aisle to get hex bugs and take them apart. But Grace Hopper did that too. She took apart clocks and she worked with them, and now she's a huge role model today. Okay, so why should women code? First off, we need more programmers. Imagine how much more things we could get done faster, and the whole modern era would be so much more advanced. Also, women can code just as well as males, and more ideas get spread around. We'd have more input from different people, and we'd have so much more things today. So here's one of my favorite quotes from Grace Hopper, which are, "Humans are allergic to change. They love to say, we've always done it this way. I try to fight that. That's why I have a clock on my wall that runs counterclockwise." So I run my clock counterclockwise, and I hope you do too. So thank you, have a wonderful day. My YouTube channel is Ellie Galloway Jewelbots, and you should find me in case you liked what you heard. But other than that, I hope you have a wonderful rest of your day at the Node.js Interactive Conference.